Hello. Welcome to the second session of Project Tours, CNCF Project Tours with CNCG Ahmedabad, Cloud Native Ahmedabad Group. Today we have got Sayan Mondal. He's going to walk us through LitmusChaos project. He's a maintainer for the project and he works as an SD2, a senior SD2 at Harness. Sayan hails from Kolkata, city in the eastern part of India, also fondly called as City of Joy. Let's figure out if Cyan is going to make it a chaotic talk about Litmus Chaos or a joyful talk. So, yeah. And as far as the team members we have got here, it's going to be me, Shivlal, and Sandeep. We have been trying to organize as many virtual tours as we can. We have got a pretty good lineup for next few months at least. If you are hearing this and would like to give a virtual talk, talk about your project, whether you are a contributor or maintainer of the project, feel free to reach out to us on the Cloud Native Ahmedabad group. We'll share the link in the chat soon. So, with that, over to you, Sayan.
Awesome, thanks. I hope I can make it joyfully chaotic. Let me start. All right, awesome. So I've already been introduced, and it's great being here. It's great being a part of this. So before I jump into any of the chaos engineering or any of the litmus chaos specific topics, what I just want is to talk about resilience, right? So I'm going to start layman, but don't just be bored yet. I'm going to go into the details and then I'm going to talk about the architecture and then a little bit about the project. And then we can see a demo, hopefully, if it works out. So, resilience in tech is kind of like how we handle unexpected changes in life, right? So, imagine you are on a road trip and suddenly you hit like a detour. So, a resilient system in this case would be like having a GPS that reroutes you instantly. So, you still reach your destination after switching, but without much trouble, right? So, at its core, resilience means three things: adaptability to change, maintaining functionality, and performance stability, right? So I'm sure when I go through this talk, everybody will have a lot of questions. So if you have questions, I'll be glad to take them in the end, but I'm sure most of my slides might already clear quite a lot of the questions that you might already have. So when it comes to adaptability to change, right, what I mean is a resilient system shouldn't be rigid. Like it can adjust to new conditions, right? So like scaling up when traffic spikes or handling unexpected failures. When you talk about maintaining the functionality, so even if something breaks, the system should still be able to keep running, right? In some capacity instead of just completely shutting down. And also, when it comes to performance stability, we should ensure that the users don't see slowdowns or crashes even when things go wrong in the background. So, if I just have to take an example, maybe think about how Netflix still streams smoothly even when the data center goes down, right? So, Netflix were initially the pioneers of this, so kudos to them. But what does this really mean for us? Because failure is inevitable, right? Machine crash, networks go down, and unexpected bugs do appear. Without resilience, one small issue can bring everything to a halt, leading to downtimes, financial losses, and so on and so forth. So, resilience isn't just about surviving failures, it's about being afloat despite them. So, this is what my talk today is all about. All right, so let's make this more real by looking at Kubernetes because that's where resilience really shines in action. So imagine a pod that suddenly disappears, right? Maybe the node it was running on had an issue. Kubernetes detects this and reschedules the pod on another node. Since the dependent service is still running fine, the application doesn't break. Now, sometimes the system itself evicts pods, maybe due to resource constraints or policy enforcements. A resilient setup ensures that the pod finds a new home quickly without impacting the app, right? So this is where things we have things like pod disruption budgets, PDBs, and horizontal scaling to handle such sort of scenarios smoothly. Now, here's when things get a little tricky. So if a database or API slows down, the app can start lagging or even failing. So a resilient system would handle this gracefully, maybe with circuit breakers, like with HTO, timeouts, fallback mechanisms, instead of just outright crashing. So again, memory leaks build up over time and can eventually crash pods. Now, a resilient system will have liveness probes to start restarting the failing containers or even vertical pod autoscalers to allocate more memory if needed. So the key takeaway here is failures are inevitable, but resilience ensures that your system stays or adapts, recovers, and just keep running smoothly. And Kubernetes gives us the tool, but we need to use them right. All right. So just imagine what could happen in such complex cloud native environments that we have today, right? There are two scenarios that come to my mind at least. That's one is cascading failures, second is complicated architectures. So this is a huge challenge in today's day and age where we have such bigger enterprise applications all over, and we have to maintain and keep that reliability afloat. So imagine an authentication server that goes down. Suddenly the payment system, the payment system, that user dashboard, and even the notifications stop working. So they're all dependent on each other, right? Because it's a cloud native system. Now, this is called a cascading failure because it's a huge problem. And in fact, 80% of the cloud native application experience downtimes due to this exact issue, that something goes wrong somewhere and there's a cascading failure down the line. Now, instead of one big application, now we have hundreds of tiny services, right, running across clusters. They talk to each other over networks, depends on APIs, and relies on different data stores. If something fails, figuring out where and why can be incredibly difficult because it's so complex. So sort of unpredictability is the default in my mind. That is how I would term it. Now, containers can crash due to resource limits, nodes go down, network issues can cause timeouts. And because we are scaling dynamically, the system is always changing, which means new risks appear constantly. So, how do we build resilience in such an unpredictable world? We come to the cloud native problem, which is definitely not a solution, but another problem. So we are proliferating deep down into this reliability challenge because we have this pyramid on the right, right? Imagine this as your infrastructure cloud pyramid. At the top, you have your application, and then the dependencies that your application depends on. And then you have the cloud native services like Core DNS, Envoy, Prometheus, and so on. And then lies your Kubernetes service. And at the bottom lies the platform services, the infrastructure layer. So there are so many things to it. There's so many layers to it. But oftentimes what happens is we rely on certain tools and we just test the top of the funnel. And then once we see that our application dependencies are fine and our application is fine, it should be fine. We incorporate so many E2B testing, A/B testing, and whatnot, but they're all in the application level. We never really go down the layer and check what's going on. So that is where chaos engineering or such practices of testing your infrastructure really shines. Now, there are so many hundreds of different microservices, right, that runs on many platforms. Now, imagine the level of cascading failures this can save you if you incorporate a practice like this. And when I talk about failures, we can't miss downtimes and outages are expensive. So they lead to financial losses, which is the main problem of this, and also reputational damage, and of course, your frustrated user experiences and so on. So some of the biggest tech giants have experienced it, massive failures due to different type of issues. Sometimes the problem is in the application itself. Let's say bad code, unhandled edge cases, or even unexpected system load. For example, a series of cascading failures took down Slack, which impacted thousands of businesses worldwide because so many of them depend on Slack. And another case was during incidents, service often log too much data and retry too aggressively, which sort of overloads the system even more. So what's the result? Users can't really access services, leading to lost productivity, frustration, and drop in trust with the specific org, right? Even with the cloud providers in Kubernetes, infrastructure is never 100% reliable, right? So you could have device failures like hard drives crash or power supplies fail, memory leaks building up, and so on. So one case specifically I can point out to is a financial company that lost over $55 million because of a failure in one part of their infrastructure that prevented transactions from processing. Now, this is again me rolling back to the things that I talked about before. Just imagine one part of the infrastructure that prevented a transaction from happening. Just the scale of impact is significant, and a single infrastructure issue leads to millions of dollars lost per hour. And sometimes it's not the code or hardware, right, but also how we handle these incidents that makes things worse. So if auto scaling is not configured correctly, let's say, then services crash under unexpected load. And if teams don't have the right alerts, just They don't even know what is wrong until some user starts complaining. So you need to figure out how to handle this incidents better, right? So for example, there's 75,000 plus passengers that had their travel plans disrupted because an airline's IT system just went down. So ticketing, boarding, even aircraft positioning, everything was impacted, right? So what was in it for them? So there's a PR nightmare and millions in refunds. So not a good day. And there's also a very famous outage that recently happened, which I won't say anything about, but you guys already know what I'm thinking of. So it is really expensive, and we should 100% avoid them. There are multiple ways of avoiding them. Please avoid them. All right, so here comes chaos engineering. This is what we are here for. What is it? The definition is simple enough. It is a process of testing something which to ensure that it can withstand disruptions. But really, at its core, it's basically a simulation. Imagine a game where you're simulating breaking something which is dear to you, so that when actually something happens in production, you are more prepared for it. So it's like a proactive approach rather than a reactive approach. So it's more proactive that you are testing things so that when the time comes, you're ready. So most teams react to failures when they happen, but with chaos engineering, we flip that approach. We test failures in advance so we can fix weak points before they become real problems. Now, when we introduce control failures, we're not just crashing things for fun, right? We're looking for answers. Now, what are these questions? So, things like how does the system behave under stress? Does it self recover, or do we need manual intervention? Which components are the weakest links in your application, in your infrastructure? So by analyzing failures systematically, we sort of identify the hidden vulnerabilities and fix them before they cause real downtime. And in the end, at the end of the day, the goal is simple. We want less downtime, more reliability, and better user experience. That's all. That's all we're looking for. So by constantly testing and improving, we make sure our applications stay online even when things go wrong. So instead of fearing failure, we make this failure a part of the process. And there's so many different ways of doing it, like there's game days and whatnot, which we'll talk about. But yeah, that is the gist of it. So don't be afraid of the failure, just make it a part of the process so you never fail. Now we move into the principles of chaos engineering. What is it at its core? So there are 5 steps to every chaos engineering process that is out there right now. So we start with selecting the systems to test. We first identify what we want to test. We then move on to the chaos experiment, selecting the chaos experiment, which is very important. Selecting what you want to do. Maybe you want to simulate region going down. Maybe you want to inject a latency in your database to see how transactions flow. So you need to find a scenario that actually resonates with you, because maybe you might be an e-commerce application which relies heavily on transaction. So you might want to test that, or something like that, right? So you need to figure out the niche area where you want to test. Then you need to run these experiments in the target system. Fourth is very important. You observe the results of the target system. And then fifth, using your observability tools and what you figured out, you need to improve. So use those learnings to improve. So this is the cycle that continuously goes down, just like the DevOps loop and everything. So this is at its core the principle of chaos engineering. Now, before we even talk about better ways to do chaos engineering, let's just look at how it's typically done and what's not always that effective, right? So a lot of organizations went down this road and just wanted to adopt chaos engineering when it was like early in the chasm. So right now, if you see, it's like in the middle of the chasm. Quite like, I think between 2020 2021, it was like early chasm. Now it's like a lot of companies have started adopting it, a little bit hesitant to, but they know about it. So it's a better phase, I would say. But yeah, a lot of organizations wanted to adopt it initially, but they struggled because of the outdated and ineffective approaches that. So just let's break it down, right? So in many teams, chaos engineering is seen as an SRE only responsibility, which is still a stigma as even today. But it is still seen as an SRE only responsibility, and developers aren't really engaged, even though they are the ones writing the code that runs in production. So this is a problem, right? If developers don't see chaos experiments as part of their workflow, reliability improvements take longer. And a lot of the chaos testing is done manually today or in isolated environments instead of being a natural part of the CI or CD pipelines. If it's something that happens only when people remember to do it, right? And chaos engineering is equal to game days only is another concept. So many teams rely on game days, where they schedule these chaos tests once in a while to see how the system behave. But a better approach is to run automated chaos experiments regularly and not just during planned events, right? Just make it a part of your life. Um, and then we have observability tools for chaos experiments and that are not really standardized, because every enterprise builds its own custom stack to monitor failures. And then you might be in a situation where you don't know which tool to use. Should I use this? Should I use that? Will it be monetized later? Is it really available? Is it really solving what I want to solve? Can I even expand more on it? There's so many questions I have. So you need to figure out what you want when it comes to this, and this is what's going on in the market right now, which I'm very transparent about. So the management wants to know, right, is chaos engineering actually making our systems more reliable? So most teams don't have a clear way to measure this today, because there's no standardized chaos metrics that the company because companies build their own measurement systems again. So there's no standardized chaos metrics, right? So it's difficult to justify the investment in chaos engineering for a lot of orgs, and that is another blocker in adoption. And a lot of chaos testing today is just planned and executed manually, because it's not, like I said, a part of the process. So the problems are these traditional approaches make this chaos engineering flow slow, limited, and hard to scale, right? So how can we make it better? So we want to make chaos engineering more collaborative, automated, and measurable, and that's exactly what we're here for. So we know chaos engineering helps us prepare for failures, but right, but how do we do it the right way? So just randomly breaking things isn't enough. We need a structured, scalable, and collaborative approach. One that makes chaos easier to adopt, right, and integrate into your workflows. So like I said, reliability is not just an SRE problem; it's a team effort. So SRE plus developers, yeah, if you both needs to be involved in this. Experiments are in Git just like code, so GitOps are involved in it, and it integrates into CI/CD. So CI/CD is involved in it. So whatever I just said just negate that. So everything is the goal, right? So the goal is to make reliability testing a natural part of development and not really an afterthought. That is number one. Then you need to stop with the one-off chaos experiments, right? Just running one-off chaos experiments is great, but real reliability comes when you standardize these, use public or private faults or available experiments out there, automate and scale. I'm no way saying that you use Litmus, use anything you want, but just make sure that you standardize these practices and you pick and create a value, so that whenever you run something, it's impacting your entire organization, not just a one-off process, but rather like a way which you can scale later on. So, thirdly, chaos engineering isn't just about measuring uh, your reliability; it's about also measuring the impact that is caused by this reliability, right? So, you need observability-driven chaos, and you use a way to use these metrics to access the impact. So, we can validate whether an experiment causes an SLO violation or increase the error rates and so on. So this builds confidence by starting small, right? So the bottom line is a structured, automated, and collaborative approach to chaos that ensures the team are continuously improving without disrupting the workflow. Now, where do we start? There's so many things. Where do you start? How do you start? So I'm not saying you just go and break production. That is just absurd. So you start with your local environment, which is download Minikube or K3s or something. Just start there, just see how it works. Then go to your dev environment, then go to your staging environment. And then, because staging is almost close to prod, if everything works fine in staging, my friend, you're ready. So move to prod and then see how things work. You will definitely have more challenges in prod, because that's where the holy grail is. But in staging, if you are comfortable, then start rolling it out via different methods, like start pushing it in pipelines, start doing a smaller part of it. Don't just try and do chaos engineering throughout your entire project. Try to compile or like constrain the blast radius of your experiments. So all these things will come into play, and that's how you sort of know that when you're ready. If you feel that in staging you're doing fine, just move that small chunk to prod. So that's how you sort of roll out as you go along the way. Now, let's introduce the tool that I'm a maintainer of, LitmusChaos. Now, till this point, you learned why, how, and the necessity of it, right? So this is just one of the tools that I find really helpful, because I've been working on it for the last 4 years or so. So it has a natural way in open source for it to be very pluggable. So you can just plug in anything, the experiments, the faults, even the scenario creation, the observability, everything is pretty open. So that's why I really like this tool. Now, it is one of the tools which is very Kubernetes native. So it's built for Kubernetes. It is open source, community driven, of course. And it has multi-cloud support as well. So it's not like because you're in Kubernetes, it's just limited to Kubernetes. You can target AWS, GCP, other vendors. You can also target bare metals. So there's a lot of scope and possibility. And even if there's something which you don't find, you can always raise a PR. So this is the core of Litmus. It's a cross-cloud, cloud-native chaos engineering toolkit, or I won't say framework. It's a toolkit which you can evolve into anything and mold into anything that you want to. We'll get a demo of this tool really soon, but I'll show you how you can do the chaos through this tool. But this is at its heart, this is what Litmus does. It's an open source, sort of a plug and play type of a library, sort of a tooling which you can use and create your own scenarios or experiments out of it. So what does it feature? We want to enable resilience for you guys easier. So at its core, you can do fault injection, you can create experiments, you can manage multiple faults together. So there are situations where you might want to inject latency in the database and at the same time check if your node is down or not. So you can parallelly run those things together with Litmus. That is what we call as a scenario creator or chaos studio. And then we also have observability built right in, but it's not auto install. So there's Grafana, Prometheus that comes along with its package when you install it, but then you can just do a kubectl apply if you want to. If you don't want to, don't do it. Use your own APM tools. That is absolutely fine. So some of the advanced use cases might be adding GitOps to it, maybe working on game days, maybe multi-tenancy, maybe CI/CD integrations, and so on. And then there are certain integration capabilities like Prometheus and Grafana, which is said. There's also air-gapped environment where you can run Litmus in air-gap situation. You can also target bare metals and so on and so forth. So there's a lot of scope for this, but this is at its heart what it does. Now, these are some, not an extensive list, but these are some of the experiments available. So you can target your pods, your nodes, your network, you can maybe simulate, let's say, a load gen of some sort. There's also K6 fault that recently was contributed by our South Korea team, and that was an awesome load gen fault. So you have stress chaos, you have cloud services chaos, where you can target other vendors which are outside, which is not hosted in Kubernetes. And then you also have application specific chaos like this Kafka, this Cassandra, so many others, right? So you can do almost different, like you can target almost different angles of an application of your infrastructure, but there's also something called as the chaos SDK, and also Litmus CTL and so many other sub projects of it that you'll always find some tooling or the other related to this which you can use to create your own. And then we also have this concept of chaos hub where you can create your own private repository, put your own instrument, your own faults, and just execute something for your own org if you don't find it here. So we have the SDK, like I said, which can help you bootstrap something from scratch. Then you can use that, upload that manifest, and just execute it. So everything is available. Feel free to use it. All right, so this is the architecture diagram, the first level of the architecture diagram, which I'll explain in very simple, short terms, right? So you start with your application that is there on the absolute left side. So there's some application you want to target. You connect Litmus. So you host Litmus first, and then you have two planes. You have a control plane, you have an execution plane. So control plane is where the UI, the chaos center, the auth server, the database, the GraphQL, and everything relies, right? The authentication, everything. In the execution plane, we have our business logic, where we have our subscriber, we have Argo, which is our Argo workflow controller, and then we have our exporter, which exports these metrics, and so on and so forth. And then we have three CRDs, which are really important, which I'll talk about next. But this is where the discovery, the RBACs, the policy validations, and all the business logic happens, right, in the execution plane. And that is where it picks different faults, executes them, installs them, generates the result, and shows you the result. Now, these are the three CRDs which I mentioned, and these are very important going forward. So we have chaos experiment, which is like chaos intent specified via images, libraries, and so on and so forth. It's like a definition. Imagine like a blueprint that you can use to create your own chaos experiments. Now, chaos engine is also part of that blueprint. Now, it is basically what gives meaning to that fault. For example, what I mean is, if you want to do, let's take the example of a latency. All right, if you want to do network chaos, right? So network chaos would have a CR, a blueprint that defines, okay, this will run on this target, that target, and then you have certain tunables like ABCD. You want to run this in this blast radius, you want to run this in this target container, this would be a pod affected percentage, and so on and so forth. But in Chaos Engine, you would actually tune that. You'll say, okay, no, I want the pod affected percent to be 100. I want the chaos duration to be 60 seconds. I want it to be 120 seconds. So engine is what overrides the experiment, if that makes sense. There's a blueprint. Engine is the area where you can tune your tunables. An experiment is the segment which defines the library, your necessary permissions, your low-level chaos parameters, and so on. And result is the final one. When everything is finished, it is sort of taken out and stored in the result. So you can take that result back home, and then you can, not back home, you can take that result and then you can use that result as a way to analyze what's the outcome, what is the verdict of my probes, what is the verdict of my experiment. If I run everything parallelly, which one failed and why did it fail? So the logs of it, everything is stored as part of the chaos result. All right, so this is what I just said. So you have a hub, which is the central repository where all our chaos experiments are hosted. The way it works is there's a chaos operator sitting right in the middle. That is our main guy. So he's looking at the different policy validations, the RBACs. It's reconciling everything basically. He's just there at the center. So you start with your experiment. You pick that. Let's say you pick the latency experiment. So the blueprint comes in. You modify something. Chaos engine comes in. You schedule it. Then it spins up multiple runner pods. So the runners are basically another helper that helps spawn multiple chaos jobs. So these jobs are the main injection points. So let's say if you want to inject latency every 30 seconds, right? So you say my chaos injection duration is 120 and my interval is every 5 seconds or every 30 seconds or something. So after every 30 seconds, there'll be one new chaos job, another 30-second, a new chaos job. And this is being spawned by the chaos runner at the top. So you have the chaos runner and then you have multiple chaos jobs spawning after each interval that you define. Like after 5 seconds spawn someone, after another 5 seconds spawn someone. So this is how it works ideally. And then all these are taken out, the scheduler, the export metrics, the event exporters, and so on. And then everything is stored in the chaos result. And these exporters do help you with the monitoring and observability if you want to use some other tooling, right? So you can instrument them with these exporters. All right. So this is another thing which talks about the same thing, which I won't go into too much details, but yeah, you initialize it, then you execute the chaos. If it's completed, very good. You have your chaos results. You can stop the reconciliation, and it deletes all the resources gracefully. So there's something in Litmus which is called as a cleanup chaos. So it's turned true, or it's turned to on by default. So whenever you do the chaos, whatever is finished, right, whatever is remaining of the extra dependencies or extra jobs that were created as part of the chaos are gracefully cleaned up after the chaos is finished. You can stop this behavior because it sometimes messes with the logs of the chaos. If you want to look at what exactly happened, something failed, I want to know the reason why. So you can turn it off. It's on by default, so you can turn it off, and then once it's done, you can see what went wrong with your chaos experiment, and then you can play around with the logs and figure it out. But ideally, if you turn it on, then the logs are gone. So if something happens, if it's stopped, then again you can reapply the chaos engine, and this cycle continues. And once it's finished, it sort of stops the reconciliation and deletes all the pods. All right. So it's finally time that we see Litmus in action. So what we'll see is we'll see the experiment design, we'll see the chaos injection, and then we'll sort of try to analyze and see the logs and how exactly things are, what are the probe results and all that, right? So let's get started with the same. Okay. Let me, one second, let me reshare the whole screen. Okay, so this is Litmus. I hope you guys can see the screen, and this is my terminal. So I have two things. This is Litmus already running. I have it installed, and this is my demo application, which I'm going to run chaos on. I'll show you the application. I'll show you what this means, but I'll show you Litmus first. So what is this? Initially, when you start, right, we have Mongo by default set up for you guys for the database, and it's a high availability HA Mongo. So you see so many different versions of it, right? So this is just the database we use. We have our workflow controller, and then we have our three auth server, the front end, and the server main thing, right? So this is the control plane that I talked about. So you have your control plane. Remember the architecture. You have the control plane first. So this is where everything goes on for the as part of the control plane. Now to inject chaos somewhere, you need that infra, right? You need that somewhere. You need an agent where this thing can connect to. So in my case, I have a cluster where I install Litmus. Now I want to connect the application where, or I want to connect the cluster on my infra where my target application is residing. So just for the sake of simplicity, this application is also on the same node, on the same cluster. So what I did is I went ahead and also connected the infrastructure. So that's why you see all these extra things, right? So you see the exporter, operator, event tracker, subscriber workflow controller, and so on and so forth pop in, which was part of the chaos execution plane, right? So everything together makes up Litmus. So this is automatically installed whenever you log in and you jump into the execution plane, right? So this will be automatically done as part of the execution. And this is my target application. So this is nothing but a microservice application which has a hat, a arm, a leg, and everything. So let me just refresh. So this is the microservice application. Everything is a separate microservice. The hat is a separate microservice. There's a arm, there's a leg. Each of the arm is different, and there's a potato main, which is like the main website, right? The main front end. So this is what it is. I'm going to try to do a couple of things. Since we have a little bit of time, I will do two experiments. I'll try to be very quick about it. We'll do a DNS spoof. So we'll see how we can spoof a DNS, and we'll also see how you can inject a malicious header into an HTTP API, right? So that can be two things which might happen. One could be an attacking scenario where you're sort of practicing security chaos engineering. The other could be something where actually something goes wrong in your DNS and your entire website goes down. So we'll see that. Let me just make the watch statement back again so you can see things installing and all that. All right. So while this goes on, let me just give you an overview of this platform, right? So I mentioned your application, your infrastructure, your agent needs to be installed. So that happens in the environment section. So right now, this is called KubeCon because we had this before. This is, we just kept the name. So this is the KubeCon and we have a KubeCon infra, of course. This is the infra. This is what I just showed you. This entire cluster is called KubeCon infra. And my application happens to be in the same cluster, but if it was not, then you could have easily gotten like installed another infrastructure and done so. And let's say you have two clusters, right? You do not have one single cluster. You have one cluster where you do your business logic, one cluster where you install your application. So in that case, you can use something like LitmusCTL. Let me just search that up. So this is another tool which you can use if my internet works. Yeah. So this is another command line tool that allows you to merge or manage the chaos Litmus's agent plane and to sort of connect other delegates and so on and so forth. All right. So you can explore this later, but just in case you have that sort of a setup, you can also target multiple other clusters in other like environments, basically. So since I have both of them in the same cluster, everything is connected, everything works great. I have my demo application set up. I have my Litmus setup. Cool. Now, there's a concept called resilience probe, which is like pluggable checks that you throw into your system to ensure consistency and data validations and whatnot. And after 3.x, we sort of made it mandatory. So you have to have at least one resilience probe in it. And it's not difficult. You just need any sort of business logic, right? So what we technically do sometimes is we use health check as our main parameter, right? So what is health check? It is basic, it could be anything. So for this one, it is just a very basic one. It just says that okay, if my potato head application is running in this uh, target port, and if the get method is equal to 200, which means it's actually healthy and running, then just say it's healthy. That's it. So it could be anything, but this ensures that you think more proactively when you're doing resilience testing. Now, it's a very simple example. That's not always the case. You can go as crazy as you want. We have some other probes, which like if the service is up, if the node status is up, and things like that, Nginx and whatnot. But that's the core of it. And then we have the chaos hub. Now we have a couple of them. These are private or like personal hubs that I connected, but this is the one that comes with the default installation. So you have a couple of scenarios, you have different faults, and there are so many faults. If you want to look at it and not install this right now, what you can do is to hub.litmuschaos.io, and this is the central repository of the chaos hub that is publicly available for everybody right now. So you can just go ahead and filter via Azure, GCP, Kubernetes, VMware, whatnot, and you can see for yourselves what these experiment contains of the documentation for them and so on. but this is embedded as part of the resilience platform when you install it. So that's that. We don't need to dive too deep into the other aspects of it, but let's just start with the experimentation. So there's a couple of experiments we have on this particular platform, but we'll just focus on two. We'll just do the potato header injection and the DNS spoof, right? So let's just start with DNS spoof because that's always the fun one. So let's click on it. So the way you normally schedule it is you click on new experiment, give it a name, select the infra, and in this case if you have multiple, then this will pop up. And once you do that, there's a choice that pops up at what type of infra do you want it to be. You have templates, and in the initial scenario I did mention, right, that you can bootstrap your own fault and then upload it. So this is the upload YAML part, so you can upload something of your own. If not, then you can just do blank canvas. So let me go back to select the DNS one, which I already configured, and click on it. So normally you click on this add button and this thing will open up anyways. So what I'm doing here is I'm filtering. So I'm saying the app kind has to be deployment, the namespace has to be demo, and the app label has to be name equal to potato main. So these are all configurations as part of this this setup. Let me just zoom in a little bit. One sec. Yeah. So these are all there as part of this setup. Now, if you can see, the namespace is demo, and this is the potato head application. So this label is already there, and the way we are tuning it, this is the chaos engine part that I mentioned when you're tuning things. So this we are tuning the chaos engine right now, and a lot of this is like automatically present as when it comes with the hub. When you import it, it's just present there. What I have manually added is this guy. So I have said that I want a spoof map. So I want one service to spoof another service in my system. So this can be any other system. If you notice carefully, I have this FQDN link, right? But this can be different, which might reside on my another cluster. So if anybody has access to my cluster, if there's any dependent service, and if somehow one service is getting spoofed, or there's a chance that it may be spoofed by the other one, just imagine the havoc that could happen, because they are both duplicate or similar services running between multiple nodes, right? So if I just go back here, you would see that there's a potato hat and there's a potato hat new. This is the pod, by the way, but these are services, so they have the same services. So I have installed it in the same namespace just for simplicity, but just imagine the scenario, right? So what I want to do is spoof one microservice to replicate another, which is not exactly healthy or safe in that case. So in the demo, it is of course safe, but it could not be in a real life situation. And then we have another probe, which is just the health check probe, running it in the start of test. That's it. So if we just save this experiment and run it, right? So what we are expecting is, since we targeted the left arm of this guy, sorry, the hat of this guy, so we want this hat, this microservice, to change to the other microservice. And in this case, we have made a really, this hat new is a very fun microservice. So this will give this guy a pirate hat at the top. But that is just the crux of it, right? So if you are in a scenario, if you are in a place where things might go wrong in the same cluster, so if an attacker gains access to it, or if you have multiple applications running in the same cluster, and then one application sort of indirectly calls the other application, just imagine the mismatch of the services, right? Because you might have service meshes and so many other things working together. So this is one small scenario which you can pair. And for this, I use the Chaos Studio, by the way. So these are the logs that will come up. You have the fault configuration, you have the probe and everything. So probes are a work in progress, so it's NA for now. But let's just go back and refresh. So you see this, so you see this guy change the hat, right? Because now the microservice is completely different. Now let's look at what's going on in the watch. So I have a watch command just so that we can see the sequence of it. So initially you see, if you remember, I said there's a runner, there's a helper, there's chaos jobs, right? So up to here we had the workflow controller. Then the main experiment came in. Then this guy spawned up a runner, which spawned up a helper here, and then we have these there's a helper, and then we have these individual chaos jobs, right? So these are the individual chaos jobs that are pending, container running, and now one of the job is running, which is why you see this spoof happening at the moment, right? So this is one scenario that I would like to highlight as part of the chaos injection. And you can imagine the different sort of scenarios we have here. So you can mix and match and just play around and create like a scenario out of this itself. So there's a latency, there's a network corruption, there's a node drain. A very popular DNS fault that you can pair with this one is DNS error, because then you are sort of seeing once you inject once you are in, like let's say you SSH into a specific service, can you sort of reach out to another external endpoint through that service, because that could also be crucial, right? So if you're communicating between multiple microservices and you're SSHing into a specific service, then is the service actually able to communicate with any other service externally? So in that scenario, you would do like a DNS error inside that service. So DNS spoof, DNS error, these kind of scenarios could be very helpful when you're thinking about Kubernetes networking, right? So if you want to target the networking and check if your services networking is good enough or not. So that is one scenario. Now let's move on to the other one, which is the header. So header is quite similar. What we are doing here is we are again targeting the same application and the fault in the chaos engine. We have a header map in this case. Now what the header map is, you can basically inject any sort of map in here. I can inject any token. I can gain access to any system via this, and just to test out, right, just to test out your JWT scenarios or any bearer token or any authentication system. So this would generally be used when you want to target some systems authorization keys or auth settings. So in this case, it's just Litmus test, and I just added CNCF Hyderabad, Ahmedabad. But it's again a very simple thing to do, but imagine the consequences for this. Now what I want is I want it to be as part of the response, and the target service port is the service port of the main application, which is this guy. Let me open this back again. So in the, let me just do kubectl get service. So I want to target the potato main, which is running on port 9000, as you can see. So this is the service that I chose, the node port. And for the headers, I just chose X API, X Litmus test header, just as a dummy input, right? And for probes is the same, nothing else. And these are other parameters as part of the same tunable, which you do not need to dive deep into. It's just advanced settings, but yeah, you feel free to do that. So let me just save and run. So the same thing happens. I should now, I also told you that this gracefully reverts back, so this should also be back by now. And if you see the older settings, so let me just do a kubectl watch again. All these things that were created, right, the DNS spoof, the pod DNS, everything should have been gone again. So you're back to square zero. So that's the beauty of the graceful cleanup. But let's focus on the second experiment right now. So this will sort of change your name servers, right? This will sort of try to do modifications in resolve.conf and then try to inject some sort of a external API that modifies your headers. So with this sort of an injection, I don't know, there could be so many possibilities, ransomware, whatnot. So there's a long list of things that could happen. Now you as a chaos engineer need to hypothesize what exactly you want out of it. So the experiment has started. Let me just go to inspect and the network tab. And right now, if I refresh, there should be a version that pops up. And in this, oh, okay, it's already here. So you see as part of the response header, we already have X Litmus test header and the header that I set, right? So this already has injected into my pod, which is running in my cluster. So I already have access to something which I should not. So again, so many security flaws, security loopholes. So this is how you sort of go back, analyze, think about it, and then change your security, either like modify your security, add restrictive firewalls, whatnot. So you might already have these things in play, and what you want out of chaos engineering is just to assert and test all these requirements and scenarios, right? So yeah, that is what we want, and that is just the end of my demo. I won't take much time, just move back to my slides. All right, so we are almost towards the end now. What could be the real world applications of these, right? So there's so many industries using it. There's e-commerce, there's fintech, there's healthcare. So for e-commerce, I already told about the big billion days and all these different P cards, right, that might pop up. So even with gaming industry, we are seeing this now where PokerBazi or these other adopters are sort of experiencing sudden spike, like because what happens with these systems are you do not have like a consistent spike throughout the year. So there's some event and there's sudden spike and then it goes down again. So these sort of systems, right, are very easy to disrupt when when you imagine certain load in these sort of systems. Even for financial services, like the transaction DB, the transaction example that I gave, it's very crucial. And for healthcare, you can of course imagine the emergency situations that might arise for industries like this. So everybody right now is sort of adopting a practice of effective resilience. And there's more in the Litmus adopter section and the Litmus blog section that you can learn more about the adopters and how their use case shines in these sort of scenarios. But I want to say that it is not for everyone. Resilience is is reliability really a goal for you? You need to know that when to do this, because it's not for everybody. So are you sure that you're not compromising your team's effort? How much of your developer time is actually being wasted in doing these sort of reliability? So are you losing speed? Are you losing quality? Are you losing the developer productivity? If your answer to this is yes, and you might not need an extensive setup like that you need for chaos engineering, I don't think you need chaos engineering. You should wait for the right time to jump into this trend, into this gain some momentum on this. But I don't think reliability is a direct goal. It is sort of a derived goal. Your ultimate goal should be solving the problem, and while you solve other problems, you will inherently achieve reliability. So that's mostly what I wanted to talk about chaos engineering and the project. So what's next for the project? So we are working on introducing native chaos workflows, which can help redesign the subscriber and improve your resource delegations. We are planning to add Terraform support, which will soon announce as part of a GSOC project we are doing. We also want AI support, like, because it's not because of the trend, but it's because we want proactive resilience. What it means is we want the AI system to sort of tell us how to be proactive and predictive. So the system will predict that what could go wrong. You might be using your system in ABC ways, because we have so many products right now in the market that could do that. And we have Kubernetes Lens and so many amazing tools. Now the goal is to read the system and tell you what could have possibly happened, because you as a chaos engineer might be skilled enough, but there's always scope for improvement. Right. So we also want to improve developers' productivity through Litmus. So we are just not making it for SREs or other personas, but we are adding more SDK support so that developers feel free to, add more on top of add their use cases on top of our product. And then we are integrating distributed tracing and enhancing the observability by adding open telemetry and all these instrumentations that we are planning to do. All right, so that's it. Uh, how you can get involved. So these are certain aspects and areas of the project that you can be involved with. We have our control plane, our execution plane, our experiments, our E2E, and then the deployment and the integration references. These are so many different repos. You can maybe take a picture or something, and then you can just go to the Litmus org and you'll find everything. Uh, it depends on what you want to contribute to, what your interest lies, and for that I have this. So if you want to get involved, we welcome everything from development of features, bug fixes, improvements, documentation, whatnot. So if you are a UI guy, web guy, this website for from our in our org that you can contribute to. If you're an SDK guy, a Golang guy, then you can try Litmus Go, which is our SDK. If you are more into integration references or helper tools, then you can try our test tools. And if you want the core of it, then you can try chaos workflows and charts. This is where we define and describe our faults. So how a fault is supposed to work, how is it going to inject chaos, where and why, and all that stuff. So this is just a small list which I wanted to give you. But yeah, thanks for listening to me. That's all I had for today. I hope you gained some value out of you, and I hope it was joyfully chaotic as I promised. And you can contact me on these links, and you can stay connected with the project here. And I hope you guys derive value out of this and integrate chaos in some part of your life. That's it from me. Thanks.
Thank you so much, Sayan. That was actually joyful, not at all chaotic. Um, so, are you up for some questions?
Definitely go for it.
Okay. So I'll pick first by Dhruv because it's very much directly relevant to the talk. His ask is, can you please elaborate more about the Kubernetes resilience probe and how it works during experiments?
Okay. So resilience probes are are like a pluggable check in your system. So how I would define it is if you want to inject something on top of what you're already doing. It could be binaries, it could be added checks. So we have three kinds of probes, right? Four kinds of probes: the HTTP probe, the command probe, the Prometheus probe, and the Kubernetes probe. So if you are doing observability, for example, or not, if you have some observability integrated, and let's say you are doing an experiment, right? And then you want to pull some PromQL, like add some PromQL query and pull some data out of it. So during the execution, during the chaos injection, you can write a PromQL query as a resilience probe. And when the experimentation happens, that PromQL query will be able to do what you defined it for. So you are doing extra instrumentations on top of what you already defined. So that is what it means. Now, if you want to do something extra, then you can come up with maybe a binary and then you can execute as part of a command probe. Then in that case, you're executing an SH, like a bash script on itself while you're doing the chaos experimentation. There's endless possibilities. Everything is documented as part of the resilience probe in the Litmus docs itself. But this is just a overview, like an extra step. So we have start of test, end of test, continuous mode, on chaos. So continuous is basically it's going throughout the duration. On chaos is you only want this to run when you're doing the chaos. Start of test is maybe let's think of it something. We have an edge mode. So what you would ideally want to do is you want to see if my system is live before and after my execution. So before execution, you run this probe. It checks, okay, my system is live. I did my chaos. It checks, okay, is my system backup? If that is the case, then the edge mode probe is successful. So you might want to do all these scenarios with probes.
Okay.
Yeah.
Pretty detailed and helpful answer. Dhruv, I hope that answers your question. If not, and this is for everyone, if you want to just speak up, raise your hand in the interface and we'll try to unmute you so that you can ask a question directly instead of having to write it in the Q&A. So the next question is from Sandeep. He says, great demo, Sayan. And his question is the getting started link still relevant? It shows last updated in 2021.
Okay, no, I don't think so. So we have, if you go to the docs.litmuschaos.io, our contributors have gracefully created a new tutorial section where they explain all this potato head and everything very detailed. And we have already archived this tutorials. I think we might have missed one or two links. We'll do that. But we did a tech docs analysis recently with CNCF, and we sort of archived this back a little while back. We might have missed this, but if you want the tutorials, you can of course go to the docs.litmuschaos.io, and just at the bottom there's a section for tutorials where you'll find, like, detailed what you want to do as a day zero user to day one user. We are planning to add a couple more, maybe a day one, day two use case where you also add an APM tool on top of it. But for now, you have a day zero flow on the tutorials.
Okay, thank you, Sayan. We have one more question from Shivlal. His question is your thoughts on other chaos engineering tools like Chaos Monkey.
So Chaos Monkey, we see it as the starting point for chaos engineering. Everything disrupted after Chaos Monkey. When you think of chaos engineering, everybody thinks of Chaos Monkey because that's what they did. That was the impact of Chaos Monkey. And I think Chaos Monkey was very much suited for a specific need that Netflix had. And the way they were envisioning it did not really grow out to be something bigger. They might be still improving it, they might be modifying it a bit. But the way I think of other tools is every tool has a area where it shines, right? And we love to take uh, inspiration from different tools out there, and we never enforce that you should use this tool. Whatever tool you find better suiting your specific needs, you use that tool. But what we saw and what we struggled with is we wanted to make things open, just break down the pieces so that everybody can take individual pieces and wherever they need to and just plug it in. So that's my thought related to the other tools out there. Every tool is great. You just need to focus on what niche you are focusing on. Like, you need to figure that out. If you want a smaller experimentation, and if you're just happy with what Chaos Monkey gives you, then go for it. If you want more control, plug and play, then go for Litmus. If you want an enterprise side of something, then go for some enterprise product and so on. So it depends on your use case.
Okay, thanks for that. Follow up from Shivlal, how chaos mesh is different from Litmus Chaos.
Okay. All right. So I mean, they're both good projects. But I think right now, maybe the community adoption, um, maybe the way the roadmap is defined, I think of it as a way that products and the maintainers, like the maintainers and the community, is very much involved in the direction the project is heading. So I think where chaos mesh differs is their vision, and where litmus differs is also their vision. That, like I explained, what we are up for next, we want to integrate AI, we want to do a native flow and things like that. Whereas some projects might differ in their thought process and ideation and the community support, I believe. So I personally feel, because I was part of this project for a long time, that the community support that you get with Litmus is amazing. And there's always a Slack channel you can join. There's LinkedIn, and there's so many other profiles that, wherever you seek help, you get it. And that's why, if you see the adoption chart, right, a lot of companies are actually coming up and adopting and declaring that we have adopted Litmus, because I think the flow is smoother, in my opinion. But it's just differs, because I'm a maintainer, so I'm biased.
Okay.
Yeah.
So the next one is from Dhaval. His question is, what existing technical capabilities the team or an organization should have before thinking of using chaos engineering, even if it makes sense in terms of business value?
Okay. So I wouldn't say there's like a specific prerequisites to it, but there's a very beautiful blog, or like a holy grail, I say. It's called principles of chaos engineering.org. It's where everything is defined, and it was long. It's the OG. It's the long back principles that was defined, and it just says everything you need out there. And then people, tools, market has evolved, and they have started placing things on top of that. But that is the actual definition of what the main principles are. So if you adhere to those principles, if you have those capabilities already, then you should be good with any starting chaos engineering in your org. But just for starters, like I said, it's not this specific persona for it. So if you're a developer, then maybe look for how you can integrate it in your CI pipeline, or how you can use the SDK to do it. If you're an end user, if you're like an SRE, then think of it how you can use it in your cluster, how you can maybe scope it down to a namespace and not target like open a wide blast radius. So you might need to like narrow it down to what persona you are, and then how you want to pitch it to your company. The ultimate proposition is, would this be beneficial for my company? If not, like I said, reliability is not really the goal. You improve things, and then reliability becomes the goal. So I'd say based on your persona, it differs. But I don't think there's a specific prerequisites.
Okay. So the next one, and we are having a lot of questions. I hope you don't mind
You
staying
know,
around for a few more minutes.
yeah,
Okay. So
no, this
next one is from Yash Israni. He is asking, will Litmus Chaos take part in GSOC?
absolutely. We are doing GSOC this year, and we are planning to like sort of roll out the Terraform support for Litmus, which might be a longer process, because it's you have to start the integration, and then you also want to help the community out, whoever wants to start with the infrastructure and everything. So we are in the process of defining the goals and creating the issue doc, and we will definitely apply for GSOC. We are also parallelly applying for LFX the spring term. We'll do LFX as well for the other terms, but yeah, we are doing GSOC this time.
Okay. That sounds great. Okay. So the next one is from Samir. His question is Litmus part of Harness? I saw UI similar to Harness. And also, did we touch upon a part where it shows results of experiments? Wondering, would be required to monitor things live when experiments are going on, or results can be comprehensible, consumable at later point of time, and would be easy enough for someone to take corrective actions based on it?
Yes, so the data is saved, but I'll answer the first part. So, is Litmus part of Harness? So, Harness is the sponsoring organization for Litmus. So, the initial Litmus team, right? So, they are currently the core maintainer Litmus team are part of Harness. I myself am a part of Harness. So, we have the sponsorship of Harness. Harness is a sponsoring organization, but all our decision makings, roadmap planning, and everything is driven by the community. So the way we sort of structure this project is our UI is similar to Harnesses, because we have an enterprise offering which Harness provides, but the open source version is absolutely enterprise free. So in case you want a smoother onboarding, that is the only reason we do a similar UI, but it's never enforced or anything because all the feature functionality and everything is anyways community driven, and you have the roadmap quite out there. So that's the only reason why we have a similar looking UI. And touching the second part of the question, do we have a place where this is stored? So we have the exporter and we have the chaos result as well, the main CR. So while the chaos injection is going, if you instrument Grafana or like even OpenTelemetry or something, then you do see the spikes and the QPSs and every metrics that you want to see, and they are also stored later on. So if you want to use any other APM tools, when you pull these metrics, the history will also go along with it. So if you want to change swap out Prometheus or like introduce Thanos or something, then those historical data, those metrics will still be present, whether irrespective of whatever APM you use later on. But you need the exporter when you're doing these experiments, right? You need those components. You can't just play around with the components and expect. So we do store those data, but if you plug anything later on, you should be able to get the historical data back.
Okay. All right. Seems like that is it from Q&A. I'm going to finish the Q&A now so that no more questions will be asked there. All right. I guess that was a wonderful session. Absolutely loved it. If anybody wants to speak up something, please feel free to raise your hand if you want to talk anything about LitmusChaos to Sayan. Otherwise, we would sign off. Just raise your hand and I would give you the presenter mode so that you can talk to Sayan or talk to the group in general. Going once, twice, thrice. Okay. Thank you so much, Sayan. Thank you for your time. Thank you for the wonderful presentation and for walking us through LitmusChaos. Absolutely joyful talk. And to everyone out there, we hope you have a good rest of the day, rest of your evening. Goodbye.
Awesome. Thanks for joining.